So now we're going to talk about the complex plane, and I know you're thinking, wait, what? Complex plane? Airplanes are not simple machines. They're all very complex. But that's not what we're talking about here. This is complex sort of, well, no. It's not like the relationship that I have with my family. That's a different sort of complex. Um, no, this has to do with the mathematical complex numbers, which means that it's going to involve an imaginary part and a real part. So, what is the complex plane? Well, the complex plane is similar to our coordinate plane, except for instead of having an x-axis and a y-axis, we have a real axis and an imaginary axis. So what this does is this allows us to plot complex numbers on a two-dimensional plane. So if I have some complex number z equals a plus bi, that's the standard form of a complex number. We should be very familiar with that. I can represent that as the point AB in a coordinate plane, but this is not our normal coordinate plane. This is the complex plane. So A is the real part, B is the imaginary part, so I can plot the point AB. So this is the complex plane. This already came up as a fun fact earlier on in the year, but I'll just emphasize it again that complex or imaginary numbers were not really widely accepted in the mathematical world until they were able to be graphed. So here we can graph them. All right, I want you to plot these numbers in the complex plane. Pause the video, do that, unpause when you're ready to check. So here we have the point A, which is 3 plus 4i, so I went 3 to the right, 4 up. Here I have point B, negative 1 minus 2i, so I went 1 left, 2 down, so there's point B. Point C is negative 3 plus 0i, so that's just 3 to the left on the real axis. And D is negative 4i, so that's just 4 down on the imaginary axis. Hopefully that was pretty straightforward. Next thing, absolute value of a complex number. So that may seem like kind of a strange thing, but no, we can find the absolute value of a complex number. Think about what does absolute value mean of a regular number? So a lot of times we say, well, it's just always positive, right? But what does it actually mean? Well, remember that absolute value comes from the idea of the distance from zero on the number line. Well, we don't have a number line anymore. We have a number plane, right? We have a complex plane. So the absolute value of a complex number is the distance from the origin. So that's why this is actually representing the distance formula. Also, think about how does this relate to vectors that we just saw. Keep in mind, and this is going to be something that is potentially confusing, but don't let it be, because I just told you that. So a vector is the form v equals ai plus bj, and the magnitude of the vector is the square root of a squared plus b squared, which is the distance formula as well. Remember, magnitude of a vector is the length of the vector. Absolute value of a complex number is the distance from the origin of the complex number. So the operation for those two things are the exact same. However, vectors are not complex numbers and complex numbers are not vectors. So that is something you are going to have to keep separate. However, they are in the same unit right now because a lot of the operations are very similar, if not exactly the same. So I want you to find the absolute value of the complex number 2 minus 4i. Pause the video, unpause when you're ready to check. All right, hopefully you got 2 root 5. We get that by doing square root of 2 squared plus negative 4 squared. So we get the square root of 20, which is 2 root 5. Okay, so we need to understand what the complex plane is for complex numbers. We have a real axis and we have an imaginary axis. It is very similar to our coordinate plane, except for instead of x and y, we call it real and imaginary. Also, keep in mind, and this is going to come up even more in the next video, that complex numbers and a lot of the operations that we're going to do with them are very similar to vectors. They are not vectors, though. Okay, so how do we determine the difference? Well, do I have just a single I term as the second term in the complex number, or do I have I and j for my components of a vector?